Right. Um, so in the last video that I made, I used an animation, and so how do I like make these animations? What's the process behind it? So the thing is, recently I've made some updates to Trace. Trace is the application that I'm using. I won't even call it an application, it's just a web page basically, but a very powerful web page. So let me just show you something. So this is an animation as well, and this is a bit more than just flipping a table. So I'll show that as well, but first let's just show this thing. So yeah, it's an ellipsoid and it's rotating using a rotation matrix, and at the same time it has this pointer arrow thing on top of it, which is rotating as well. So these are actually two different objects. So one is just data object and one is normal object, and we are updating their values. So in data you have this XYZ array thing. We are updating the values in those arrays, and then we are plotting the data object and plotting the normal object, which is happening over here. Mesh plot, mesh plot. Transform basically updates the values. So if I run it again, I mean it's just addictive. I want to run it again and again and again. But yeah, this is the thing. And also I've made this new function clearF, which clears the frame only, right? So previously the clear function that would clear the whole screen. Now I'm using clearF, which only clears the frame. So you know, if I like drew something over here, and then actually just run it like that, and then I ran this, well, this is not getting affected at all, and it stays the same. So this could be used for, I don't know, presentation on the same slide. Yeah, it could have multiple uses. Anyway, that's the way this works. Let's also show you another animation. So this is just one of the 3D animations. This is another thing. 3D animation turning a table. Copy that. Yes, this is the one. Fine. You know what, just reload the whole thing. Okay, cool. Right, let's go. Oh yeah, so actually I've got rid of this function, so I should probably do it like this. So it should be rotation matrix, this stuff, and then transform. And now let's try to run that. And this is the animation that was in my previous video. So it's basically just rotating about this axis. So from -1 to 1,1. Sorry, I'm on a laptop, so it's not, you know, working as smooth as on the touch screen. But yeah, it's basically rotating. It's basically rotating like this. So yeah. Okay, let me show it once again. So that's how it goes. How do I make these rotations happen for any object? Well, I do that using I think it's called the Rodriguez formula. I'm just gonna call it the 3D analog of complex number, you know, formula, which was the Euler's formula. So the 3D analog of that. I guess I should probably search it first to show you. So I actually made a whole video on, you know, rotation matrices and transformation matrices and all that stuff. But this is the formula that I'm basically using. So it's called Rodriguez formula. This is not the one. No. Rotation. Right. Okay. So apparently there are two formulae. I didn't know the first one actually was existent. Anyway, this is the formula. So this has, you know, a simple kind of derivation using just vectors, or you could also go with, you know, making a differential equation for your rotation matrix and then solving that differential equation. And by solving, I basically mean guessing a solution and then proving that that solution makes sense as well as it is the solution. So yeah, and I'm not gonna go into derivation. I already have a video which, you know, describes all of that. In fact, I'm gonna show you the whole thing. So go to home. Okay, don't look at all of that. That's not important. Yeah, rigid body motions. This was the one. So yeah, this is the thing. So I made a video on this and you should watch that first. But basically here we come across this formula, right? So this is actually the matrix that I'm implementing. So the angle A that we have to put in rot m function, that's basically the angle theta over here, and omega 1, omega 2, omega 3 are the xyz coordinates of the array that we have to put for capital W in your rot m function. And this gives you the rotation matrix. Yay. And so applying the rotation matrix a bunch of times, you basically stack up your theta values and then it becomes a big theta value, and then you get, you know, rotated to certain angle. So I'm using pretty small theta values actually. So my animation is more like update show rather than as a parametric curve that you update by finding all the values first and then you show. I'm not doing that. Instead I'm using the old values and then just updating them, right? I guess that's simpler to do. I could always go with the other, you know, method, that is changing my matrix accordingly and then just, you know, creating a new array every single time, or I could just, you know, use a reference array, you know, the starting point. I could use that, and then using that I could always calculate the current position of my object. So that's another way I could do it, and I guess that one is more useful, but for now this is all I have to give you, right? You can do functional animation by doing that. Awesome. And that's it. I'll see you guys in the next video. Oh, okay, I should also tell you about this thing. So yeah, this is actually sort of like my personal website, although it doesn't have domain, like a good domain name or anything, but this is pretty much my personal website, and its about page is actually on simple.ink. So this is actually on simple.ink, and this could be optimized for search engines, but I'm not gonna do any of that. Yeah, because like I doubt anybody is actually going to look for it. So there we go. That's it. I'll see you guys in the next video.